Have you ever wondered what Korea's National College Entrance Exam, the CSAT, actually looks like? What kind of questions do students face on this incredibly challenging test? This is a 2-point question, and students are expected to solve it in less than 1 minute. Ready? Let's go. Here is the original question, presented in Korean, just as it appeared on the actual exam. It includes two figures that we'll break down in detail. For clarity, let's look at the English translation on the next slide. Figure A shows the tracks of typhoons A and B, which affected Korea in different years. Figure B illustrates the changes in atmospheric pressure, wind speed, and wind direction, observed at Station P over 36 hours, while it was impacted by either Typhoon A or B. The question asks, which of the following statements about the given data are correct? We have three statements to evaluate. First, does Figure B show observational data for Typhoon A? Second, at Station P, is the wind speed at time t1 faster than at time t4? And third, is the distance between the center of the typhoon and Station P greater at time t1 than at time t3? Before we tackle the problem, let's review some key meteorological concepts, specifically how wind direction changes in the navigable and dangerous semicircles of a typhoon in the Northern Hemisphere. Remember, in the Northern Hemisphere, typhoons are low-pressure systems with a counterclockwise inflow of air. Imagine a typhoon approaching. Initially, we might experience winds from the northeast. As the typhoon moves, this could shift to a northwest wind, then potentially a west wind. If your observation site is located in the navigable or safe semicircle, the wind direction will generally change counterclockwise, moving from, say, northeast to northwest, then west, and finally southwest as the storm passes. This is a key indicator of being in the navigable semicircle. Now, let's consider a different scenario. What if we experience winds from the southeast? This might then shift to a south wind, followed by a southwest wind, and then a west wind. If the observation station is located in the dangerous semicircle, the wind direction changes clockwise. For example, moving from southeast to south, then to southwest, and finally west, as depicted here. This clockwise rotation is a clear sign of being in the dangerous semicircle of a Northern Hemisphere typhoon. Now, let's return to Figure B and analyze it carefully. The graph doesn't explicitly label which line corresponds to which vertical axis, so we need to deduce this. The bold, solid line shows a value that decreases significantly and then increases as the typhoon passes. This pattern is characteristic of atmospheric pressure, as pressure drops closer to the low-pressure center of a typhoon. The light solid line shows a value that first increases and then decreases, which indicates wind speed. Wind speeds intensify as you get closer to the typhoon's eye and then subside after it passes. The dotted line represents the wind direction. Observing the sequence, the wind changes from north to northeast, east, southeast, south, and then southwest. This is a clockwise rotation. Let's evaluate Statement A. Figure B shows observational data for Typhoon A. We just determined that Station P is in the dangerous semicircle, as evidenced by the clockwise wind shift. When Typhoon A passes, the observation station is located on the right side, the dangerous semicircle. Therefore, this statement is correct. Next, Statement B. At Station P, the wind speed at time t1 is faster than at time t4. Let's refer back to Figure B and look at the light solid line, which represents wind speed. At time t1, the wind speed is relatively low. It then increases, peaks around t3, and decreases again. At time t4, the wind speed is clearly higher than at t1. Therefore, Statement B is incorrect. The wind speed at t1 is slower than at t4. Finally, let's assess Statement C. The distance between the center of the typhoon and Station P is greater at time t1 than at time t3. We know that the atmospheric pressure is at its lowest and wind speed is at its highest when the typhoon's center is closest to the observation station. Looking at Figure B, both the minimum pressure and maximum wind speed occur around T3. At T1, the pressure is much higher and the wind speed is much lower, indicating the typhoon was further away. This means the typhoon was closer to Station P at T3 than at T1. Therefore, the distance between the typhoon's center and Station P is indeed greater at time t1 than at time t3. So, Statement C is correct. This question truly tests a student's ability to interpret complex meteorological data under immense time pressure. Based on our analysis, statements A and C are correct. This is what Korea's CSAT really tests.